Hello everyone. My name is Fran. I'm based in Spain, 3 a.m. here, and super excited to be here at 3 a.m. talking to you about Giza. And I'm Fran, the CEO of Giza, mostly in charge of the machine learning side, architecture, and everything related to the tech side of Giza. And I'm going to talk about one of our main products, that is Decentralized AI inference, and how we are using Starknet for this decentralization of the compute for machine learning inference. So with this product, what we want to do is provide an alternative way for people to build and deploy machine learning models. And in this case, what we are doing is decentralize the infrastructure and the compute, instead of using the typical big tech companies like Google, AWS, or Azure for doing their machine learning inferencing. We are going to deploy these models into Starknet to do decentralized inference for these models. So how do we do this? We have different components. This is a very simplified diagram of how things works. What we are doing is we take as input to our platform different machine learning models from different frameworks. We support TensorFlow, PyTorch, Hugging Face, everything that supports a standard format that is called ONNX. And what we do internally is we take all these models that are registered into the platform into this common format that is ONNX, that is very standard into the ecosystem. And what we do is feed it into our internal tool that is called Giza Transpiler. And the main functionality of this transpiler is to take this ONNX model, interpret the computation graph, how the tensors are built, the weights, the biases, which operations are being used inside the model. And this transpiler converts all this internal representation of the model into a Cairo program. And after this conversion of the model into a Cairo program, we proceed to deploying this model as a smart contract into Starknet to decentralize the compute and have different features that we'll comment later. In terms of tech stack, we have different components. For example, everything that we build is on top of Ethereum Starknet for the computation of the inferences, but on top we have different components from Giza. There are two main components. One is the platform and the other one is the protocol. The platform is in charge basically of filling this gap between how people are used to work with AI, how they work with TensorFlow, with PyTorch, etc., and to bring this usability that they're familiar, working on Google Cloud or AWS into decentralized infrastructure that in this case is Starknet. The other main component is the protocol, and when models are transpiled into Cairo and are deployed as smart contracts, we execute all the inferences as transactions, because now the models are smart contracts. And once these models are deployed into the protocol, we have many different features. For example, we have full composability, which means that all these models that are actually smart contracts in the protocol can be connected directly to, for example, DeFi protocols or on-chain games or NFTs. Everything that is actually deployed in Starknet can be composable. And the second main feature, for example, is as well ownership. Every person or the DAO or the researcher, the ML researcher that is working on these models and want these models deployed on Starknet has full ownership and control of these models, which means they can control who can access the model, who cannot access the model, and how much percentage of fee they are taking basically for the inferences. And on top of this ownership model that is built into the protocol itself, we have the marketplace that we are also building, and is from the platform side that is filling the gap between these two components. And the main functionality here is for people to be able to trade the models that people are building and deploying into Starknet through the protocol. So anyone, for example, can just deploy models on Starknet in the protocol and sell all these work that they are deploying for example, to DeFi protocols, for example. And inside the platform, we have also like different components that we are working on. For example, we have Giza 3, one of our main, let's say, work streams that we're working on very actively is on how we can actually scale these models that are being deployed on top of Starknet to have like higher throughput and more flexibility in terms of complexity that we can have in terms of the models. So we are working on our own L3 for deploying all these models, as well as like other components like more focus on privacy with integrating homomorphic encryption, as well as complete development environment for data scientists or ML engineers to work directly with their models and be connected directly into the platform for later on, like deploying into the decentralized infrastructure for the inference. But how is actually this architecture? Like we have many different pieces, but the main ones are what we call the Giza core, and are basically 3 different pieces. One is the model registry, that is like actually the entry point for people building models. And in this model registry is where we store all the models that people are uploading into the platform, like in this TensorFlow, PyTorch, or high-inference models that are being uploaded there. And we track like all the metadata, all the versioning, basically all the functionalities that you can find in a model registry, you can find it here. And the 2 other components, one is the transpiler that we already talked about, that is like a serve as a service into the platform. And there is a 3rd component that is the Onyx Cairo runtime. And this is what actually powers the transpiler, but also the models that are later on being executed in Starknet. This Onyx Cairo runtime is basically an extension of the standard Onyx format, but now instead of like being code in C++, is on Cairo, so we can have verifiable model inferences for all the models that support this Onyx format. So everything that is output from the transpiler is built using this Onyx Cairo runtime, and all the smart contracts that are deployed into Starknet using this runtime also simulates the same behavior. And on top of us, we can find as well like all the different pieces that I already mentioned, like the public L3 models, but we are also like working on private L3s, like app chains. So if there is like a specific need for higher complexity models that needs to be run in this app chain and have interoperability with Starknet or even Ethereum, we can also deploy it this way, as well as the applications like for monitoring, the notebook for people to work on their models, as well as the marketplace as well. Okay, so now that we understand like all these different components in the platform, the protocol, what we are actually building at the moment in terms of use cases, I just put 3 main use cases that we are working on in different verticals. For example, in the DeFi space, we're working closely with Yearn Finance to create this risk assessment automation for how they actually integrate the strategies into the new version of Yearn. Because now it's Yearn v2, but very soon they're going to release the v3. And basically, this is going to be permissionless to add new strategies into vaults. And the problem they have is that this assessment of the risk of these strategies is done manually. There is a person at Yearn like evaluating this risk parameters, and what we are working with them is how we actually automate this process of creating these risk scores for the strategies. So with this, we can create like a more transparency into the protocol, where they don't need to rely on a person, but also increase the speed of strategies being added into the bots. The second use case is more focused on proof of humanity, or how to verify actually that humans exist. And we are like working with this with Gnosis chain. And in the specific protocol that is the Circles UBI. And for this, we are working on generating proof of humanity solvable token for them, where we can identify which accounts are actually being run by humans and which are like just fake accounts, in order to like farm the UBI from the Circles protocol. The actual benefit is faster onboarding process, because the main problem that they have at the moment is that for onboarding new people into this protocol for the cycles UBI, they need to require people to upload a video of themselves, like proving they are humans, like with their address, etc. Actually, there is a popular video of Vitalik doing it, and it's like not a very straightforward process, right? So we are like working on how to actually detect these fake accounts without people needing to submit these videos. And the latest one is more in the on-chain gaming side. And we are like working with Dopwars and Dojo in the Starknet ecosystem in order to expand this game engine they are creating with a new component that will be based on AI agents, so they can actually enrich the game experience with NPCs. And the first going that we are integrating this new component is Dopwars, when we are creating different NPCs for doing this drug dealing that they are doing into the game, and transfer different assets that are being traded inside the game and creating their own economy. The main problem that this game had for doing this functionality is that in order to do a game, you need to wait in a lobby for people to come in. And this is not very straightforward if you are like, you just launch your game and there's just no people playing it. So how do you actually place something on it, right? So this is like one of the initial solutions where people just can join a lobby and add NPC agents in order to reach this experience and play right away without waiting for people. And if you remember from the technical architecture, there is this Onyx runtime, and this was like closed source until recently. Now it's open source. We released like last week, and now you can check it out into our Git project. Basically, is this intersection between Cairo and Onyx, and we have like a full set of features that you can actually do and use for building your own models using Cairo to have verifiable machine learning. You have quantization, tensors, rulers, softmax, dense layer, convolutionals, and much more like things that are super useful for building these models. And yeah, we are open to contributions. So if you're interested in working on and expanding this verifiable ML framework in Cairo, just pick me, and I'm very happy to help you with the onboarding process. And what is our roadmap for Giza? We have like 3 different stages. We are now in the foundation phase, where we are building strategic use cases with these partners that I mentioned and use cases, as well as we are like open sourcing all the work that we are doing in terms of the runtime, publishing like documentation, research, and iterating on the product. And by Q1 2024, we will do our public release. That is when we will open up our platform to everyone, so they can start like uploading their models and being deployed as smart contracts into Starknet. And further on in the roadmap, we have this OpenAI marketplace. That is where we will offer like this further scaling with L3s, offering this development environment based on notebooks, as well as more privacy features like most probably morphic encryption, but this is still to be seen. Yeah, that's everything. Thank you very much, everyone, for being there, listening to the presentation, and yeah, happy to answer any questions if there are any.
Go ahead. So yeah, thanks for the presentation, Fran. I'm sure everyone enjoyed it. Just a few questions, so we can maybe put some time aside to answer those. So go ahead.
Hey, Fran, question. What are your average step limits that you're running into with some of these? You were talking about these transactions. What are the average step limits?
Oh, we are actually like running into pretty high steps in terms of Cairo. So, but actually the models that we're running at the moment are off-chain, not on-chain. And we also like, for example, we ran a neural network recently, more focused on the MNIST example, something very typical. And we were running like, I think it was 15 million Cairo steps. So it was a bit of Cairo steps. Now we're optimizing that, because actually like we have like several layers in the network. We're reducing the the neurons that are available, and as well like applying some quantization optimizations. But for the models that are going to be deployed on chain, for example, the scope of these models is more limited. We are like more aiming to more classic ML algorithms like regression algorithms, decision trees, things that are not very complex in terms of computation to be run on Starknet itself.
Last question for me. We had chatted a bit earlier about like Onyx opcode implementations for implementing specific algorithms, and have those been implemented yet, or would if I want to implement like a music transformer thing, would I have to be implementing those opcodes in order to implement that stuff, or what?
We now have different operators implemented to do like neural network implementations. I don't know if for transformers there are all the operators available, but if not, like it's easily extensible to add these new implementations to support the transformers that you may need, basically. Yeah. There is also in the documentation a table with the compatibility that we have at the moment, so you can see if what you are using in your model is actually available in the carrier runtime.
Hey, Fran, can you go back to the use case slide?
Sorry, can you come again with the question? It's a bit far.
Just go back to the use cases slide.
Yes.
What is your revenue model for these?
Okay, yeah, very good question on that. What we charge is the infrastructure side of things. In this initial stage, what we are doing is helping these different partners to build their use cases. But once we launch our platform, basically we will charge for the infrastructure, even if it's on chain. We will charge a percentage of the fee for all the inferences. And in the case of the other product that we are building, that is actually off-chain computation of carrier programs and on-chain verification of the inferences, we have a typical SaaS revenue model for the things that are happening in the platform side.
And then, so what would be that price point, roughly? Are you competing with who?
Sorry, come again?
What is the price point?
Oh, it's pay-per-usage, so it's based on the usage you do of the infrastructure for running the inference and the proving. You will pay for that in the platform, and for the protocol itself, it depends on how the user defines his fee parameters, because basically the user has full flexibility on how much they want to add in terms of fees for the transactions. They can be zero, basically it's a public good, but they can be add up to 50% of the fees. And based on the percentage that they add on the fees, for the inferences, we take a cut based on that, most probably 10% initially or so, yeah.
Thank you.
Hi, thank you for the presentation. I was wondering if you had like benchmarks for how long it takes to generate some of these inferences.
Yeah, for now we don't have benchmarks because ours are actually in progress. We will like release these benchmarks most probably next month with a full set of different models, but it's something that is actually in progress.
Awesome. And like in the case that it takes too long to generate it on a client device, do you have a private delegation model so that maybe someone on their phone will be able to like generate an inference without giving all their personal information away?
Yeah, that we have this feature when we run off-chain computations and on-chain verifications. Basically, what we do is execute the carrier inference in our platform, and we send the trace to be verified on Sharp. So it is offloaded to Starware itself to later on be verified on the Stark verifier in Ethereum.
I see. So that's like a confidential where you trust like a third party with the information. Is there like a private delegation model where like forget the name of the paper, but there's ways to like generate proofs without even the prover who's like doing the work knowing the data?
For FHE.
No. It's like it's an NPC where you basically split up your private key to a bunch of shards, and then you have like the one security. Pratush Mishra, he gave a talk.
For now, I don't think so, but maybe for the future we can explore it.
Cool, thank you.
Ron, what FHE stack are you using? Because I'm only aware of Zama with like Dr. Pierre Pascal.
Yeah, it's Sama actually.
You using that too?
Yes.
Oh, I see. Yeah, I'll share the link to Zama docs with you in chat. But yeah, really protocols. So Fran, I'm sure people want to contribute to Giza or they want to understand it better. What's the best way for people to either learn more about Giza or contribute to the open source code base?
Yeah, the best way is actually contribute to the open source code base, and in the QR code that is here at the end, like you can find a link for the repository. There is a very extended documentation on how to get started, building new operators, creating your own models, creating examples. So it's a very easy way to get started. Also into Cairo, and if you're interested.
Got it. Sounds great. Any other questions from anyone?
Last one for me. Sorry. Like Dope Wars NPCs, how are those NPCs subsidized? Is that like a game sort of expense, or is that per player expense? How does that work?
It's per game. Basically, the game is based on Dojo engine. So basically, when you start a new game, it's basically a new instance into the L3 that they are running. So it creates a new instance of the game, which initializes the different NPCs that are actually being used into that game specifically. The bad thing, let's say, about this implementation is that everything that is happening to this game is based on the L3, and for now there is no interoperability, so it's a bit tricky to handle that. So let's say like the different for each game you have a different instance running for the L3.
Gotcha. Great. Well, so I think I might have mentioned this in the group chat once or twice, but we are hosting a conference right the day after STC. And we do have a few, so we're still in the works of planning that conference, but we're working on getting Giza at Fran over to talk more about what they're building here in the Bay Area. So we might be able to meet Fran in person in a couple of months. But yeah, thanks for presenting, Fran. Thanks for answering our questions. That was great. I think we'll let you, we'll be decent enough to let you go to sleep now. But yeah, I'll point people in your direction as and when they have ZKI related questions.
Perfect. Thank you so much for inviting me to the talk.
Thanks, Fran. Good night.
Bye-bye. Thank you, guys.